Hello, welcome back to my bench. Today we've got a hopefully very easy repair. This is my old Yaesu FT-840 that I sold to a local ham. He needed something to put in his truck because he drives it all over the place and for work, and he wanted to have a radio to put into his truck. This, in my opinion, is almost the perfect HF radio for a truck. It is simple. It doesn't have all kinds of bells and whistles and menu items and other things to distract you as you're going down the road. It's just dial them up, turn your power up in your mic, and talk. It's just very simple. It's a good 100-watt radio, and it's pretty well built, I got to tell you. Everything on it is very easy to see, very easy to control, and it has very quick things like lock button to lock your everything on the front, your knobs and stuff, so that you can't accidentally hit something and get off frequency. It has easy to get to memories and scan. I mean, it's just simple. It's mic power here, microphone, power out, AF and squelch is over here. Standard AF and squelch, not one of those weird little RF receive and squelch combination thingies. It has your shift over here for sideband and your clarifier here. It's just really simple to operate. It has a built-in processor, voice processor, AGC fast and slow, a noise blanker that actually does work, and an attenuator. It does not have what they call a mic preamp. Now, I got to tell you guys one thing. A mic preamp on a radio is not something added on to make it better. The mic preamp on a radio is turning on or off the first RF amplifier. With the mic preamp on, you're in normal mode. With the mic preamp on, or with it on, you're in normal mode. With it off, you have attenuated your signal by that amount, of whatever that amount is for the gain on that first stage. This one has an attenuator, and most of them have that too, which means that you throw in another few dB of attenuation for when you get a really strong signal. But on this radio, the so-called mic preamp is always on. So this one, like I said, it'll do 100 watts in in sideband and CW. It also has CW and CW narrow. It has AM and AM narrow. In AM, it'll do about 35 watts, which is all you want to do. These radios are not meant to run 100 watts in AM. You run approximately 1/4 of your peak output power when you're in AM, because AM is using upper sideband, lower sideband, the carrier in the middle, and the whole thing put together. So it's 1/4 of your output power. That's normal. That's what these things are supposed to put out. All these radios are supposed to put out in AM mode. It also has a button for FM. This radio does not have the little additional optional FM block in it, but it will do 10 meters FM. And it's just a great little radio. I mean, it's if you want something simple, easy to use, and relatively cheap out there, great radio for you. It really is. But his complaint is the meter light doesn't work. So we're going to find out if the meter light works here. Plug this thing in. Well, just sort of for right now. we'll just hook it up to the power supply. There, come here. There you go. And make sure we keep the leads separated. Sounds like a song title. All right, and turn it on and see if we got. Yep, no meter light. So power and ALC. This output meter output is power and ALC, and this is key, actually push to talk. So no meter light. This is supposed to be a simple one. Let's see. He supplied the light, and I already took the screws out the side, so don't have to watch me do that. This radio is also easy to work on, except for this little plug. There. Disconnect the speaker. All right, so let's take a look at the manual, because in the service manual it even has how to replace the meter light. And the way you do that is you take the top loose off, which we've already done, and then you take out this bolt, the nut, the bolt, sheath, that one right there. Let's get rid of the manual because you don't need it. And you loosen this one. That's it. On this side, take out this one right there and loosen that one. And all you have to do is pull this forward a little bit and down, like that. Now I'm going to set this on one of these guys, because when you pull it down, it kind of gets in the way. And we're going to show you what it's supposed to be at here. Can I get another view? Yeah. All right. This right here is the meter lamp right there. And it goes into this bundle of wires over here. And that bundle of wires goes over around here someplace. And it ends up, if we go back to the manual, it ends up in J1031, which is located in the forward edge of the main PCB. So if we go pull all this junk aside, there is, if you, I can't hardly see it. Let's bring this in a little bit. Maybe it'll be easier for you to see. Yep, there it is. J1031 is right down there. So it says, in the manual, it says, using your thumb and forefinger, grasp the outer edges of the connector and lift up the locking clamp. Okay. Get the little things out. Grab that. There's little edges. If I could get some of this stuff out of the way. There's little edges on there that you just kind of grasp it and pull up, and it pulls up just ever so slightly, like a 1/16 of an inch. And then we should be able to just pull these wires out of here. There's one, there's the other. Right there. Ta-da! So then we Well, we're going to have to cut off some of these ties. I've got these, so you know what? I'm going to loosely tie these together. Okay. Loosely, so that I can get this out of here but still keep the bundling together. And this one over here too. You kind of want it to look like it did when you got it. All right, there. And now we can cut these ties off without cutting. Oh, there's one. That's why I kept them all bundled up there with the loose ones, because it's just easier when you go and put them back in. Come on. There we go. All right, so there's those guys. And pull the lamp out of its right there, that little socket. That's where the lamp goes in. And pull them loose. There's our lamp. All right. This thing is already prepped. What was in here was a real... Let's get back to the overhead so I can show you. What was in here is a real light bulb. Apparently, what's going in here is an LED. We might, I don't know, but we might have to put a resistor in there, because I don't know what the voltage is on that light bulb. Let's find out. I didn't think about this until just now. Let's turn it back on. Power. Let's bring up the meter. And wow. We got 9 volts. So that means with this LED drawing about, well, probably 20 or 30 mils, we're going to have to do a little math here. Let's get a... Yeah, that's not it. Let's see what this thing draws. Let's put the power supply on about 2.5 volts. Hook it up. Yeah, my little hook thing on the end of this is busted. And turn down my current. See what I mean? It's no longer doing its thing. Wow, okay. So I turn the current up. I'm down to 1.8 volts. It comes on bright right about there. Wow, that's not enough for the meter to even read. Hold on a second. let's get this little guy out. Put him on amps. Select DC. Zero it off. And clamp it around there. Okay. It's reading. If I can get it to read here. It was reading about 21 mils. Try it again. 15. About 15 mils, 20 mils. Okay. So, that means at 2.5 volts. So that means we want to drop 8.5 volts down to 20 mils. Okay, hang on. Okay, so what we've got to do is we've got to put a resistor in line. If we do the math, we're saying we basically need to drop about, let's say 2.5 to 9. So we got to drop 2, 3, 4, 5, 6, 7, 8, 7.5 volts. So the math comes out to R equals E over I, 7.5, and we want to divide that by the voltage, or the current that we know it takes, which it appears to take about 13 mils, but let's just say 15.015, and that means we're looking at about 690 ohms. Well, I've got a 680 here, I think. Let's measure it just to be sure. Well, actually, that's 800. Let's try this, because, you know, you can always go higher, make it a little less bright, and it'll last longer. But let's see how bright it is with a 800 ohm on 9 volts, which is what I got on the power supply. And there it is. That's pretty darn bright. And according to this, it's drawn about 13, 14 mils. Let's try that, zero that thing again. About 8 to 14 milliamps. Of course, this is not the greatest way to do this. I mean, we could, let's see, let's take this, go to milliamps, DC, put that in there, jumper lead to the meter, okay, and let's try it directly from the output of that resistor to here, and we're looking at 8 mils, 8 milliamps. That is one effective little diode, that's for sure. Okay, well, okay, so that means we're going to go with 820 ohms. Cool. So that means we got to now we got to decide, are we going to, how are we going to do this? I guess I could just put it right in line. Yeah, I think I'll do that. I think I'll just put it in line with it. Let's get this out of the way. Give me a little room to work. Soldering weapon is on. Get out some heat shrink here. What do we got? We got a little hunk of heat shrink. I think that'll work. We'll find out. Yeah, we'll cut it there. Okay. Oh, pretty good wire on this thing. The old two-handed method, or one hand doing two things method here. Okay. Will this fit up? Yes, it will. Cool. All right. This not going to be under any stress, so I just think butt splicing this thing together will be just fine. Ow. Ah, it's warm. Yes, sir. Most certainly is. When I first started this thing, I mean, thinking about doing this thing, I didn't even think about this. I didn't. Why would they? Oh, well. All right, there's that. Turn on the blower. It's up high enough. Just want it good enough to shrink, heat shrink. Good enough. All right. Let's bring it back in here. Get you out of the way. Plug you into there. Nice fit. It's like it was designed for it. And through here. Alright, so we got to figure out which one of these is plus and which one's minus. You know, those are tinned. So we go back to voltage. And with the original light in there, it didn't matter, of course. But with a LED, it does. Come on. Alright, so that one over there to the left is plus. So we can poke him. Hopefully, boy, it is difficult to get these in here. I need a little bit of help. Let's put you up on the other camera so maybe you can see what I'm doing. Boy, that's... Can I fix that? Hang on. Okay. Turn the autofocus back on. So let's see if we can get this. Not autofocus. The level, white level. Oh, that is not tinned worth a hoot. And it definitely will not go in that hole unless it's tinned. this one while I'm at it. Okay. All right. Wow. Let's try sticking this one in here first. Wow, that's pretty tight. It doesn't help that they routed these wires there right over the top. I don't want to undo all the wires here. Okay, there's that one's in. That one's in. Mash it down. All right. And let's go back to the regular camera and turn it on. Well, I don't know. Let's see if I can pull this out a little. Maybe that'll make it not quite so pinpoint of a light. There. I don't know. I don't know if I like that or not. It's kind of iffy. Whoops. I hit a button. There we go. That's... I don't know. I wonder if I got a light that would be better. Because that's just pointing all at the front, and it just looks kind of bad. Let me go see if I got some sort of a lamp that might be a little better for this. Huh. Look what I found. 6 to 9 volt lamps with leads. I don't know when I got these or why. But let's try one. It's going to be nice and bright, that's for sure. Let's take this one back out. And make it so difficult with that thing right there. I just don't want to cut it. There. All right. Let's take this guy and stick it in there. I just didn't like the way that looked. It was just sort of, it's not diffused in any way, shape, or form. So it was just all pointing right at the center of the meter. And it just didn't look good. And I know this guy, he won't care if I use the right light for it. Okay. Let's see how this looks. Oh, yeah. I think that's going to be a lot better. Let's poke him in the hole. Now, we're going to have to come up with something, but I think we can do that with some heat shrink. Oh, my. Yes, look. That is a lot better. Oh, yeah, we're going to go with that. So, how can we make that fit? Well, like I said, we can go with some heat shrink. What have I got? Let's, to build this up. got some of this green stuff. Yeah. Let's go with that first. Turn the hot blower back on. Cut this into 3 pieces. And do it right there for the first shot. I could probably just wrap this up with tape too, but that wouldn't be quite as elegant, would it? Okay. Second layer. Let's see how that fits in the hole. Oh, yeah, that'll fit nicely. Oh, yeah, there it goes. Perfect. Fits perfect in there. Make sure it still comes on. Oh, immensely gooder. Okay. So, don't waste it. Put it back. Alright, so now, I'm not going to try to do that again. We're going to lead this through. That little thing is kind of difficult to get right. That little plug where you put the wires in. Alright. So that's in there. Turn it on. Oh, that's beautiful. I love it. Okay. Why I have these, I have no idea, but it came to the rescue. LEDswitch.com. Thank you for coming to my rescue. I don't know. Sometimes I just buy stuff, say, hey, I could use those someday. Or I get a whole bunch of crap from somebody and I just separate it and use it. Sometimes I'll buy those bags of stuff, you know, and use those too. All right, so we put this thing back together, and we'll just do some real quick tests on it. Be right back. Okay, we're back. One thing you want to make sure when you do this, when you pull these things down like this, some of these wires, for instance, get this here. Some of these wires, like right here, those will get outside. Don't mash them in. Make sure your wires are clear clear when you push this thing back down. And you just push it right back in. Get your screws. Go with the fixed screw first, because that centers it to where it needs to be. Then you can tighten that one down. And over here, you sort of kind of got to finagle it a little bit. It's a tight fit. Finagle, technical term. Okay, there's that. Get you out of the way so you don't flop down. Okay, we need a cord for the meter, and one back there. Get it on straight, David. Okay. Alrighty. Alright, so we got it turned on. Put the microphone on it and turn on the test set. And let's see if I can Okay, there's the test set. And let's see, power-wise, I'm on, let's take this up, band up. Let's say 7,200, 7.2, and power monitor frequency 007,200. Enter. We'll put this on AM for right now. The power, it's not going to put out a lot of power because of the way that I got this wired up. But we'll see what kind of power we have. We have nothing. Oh, there we go. Hello. Why I'm not seeing any power in here at all. Oh. Power. No. What is wrong? Hang on, I'm doing something stupid. Huh. Wow, that's weird. I don't really know what happened there. Anyway, I think this went bad. It's a end to UHF, and I tried. It did the same thing on my other communications monitor. It's exactly the same thing. Anyway, so I changed it out with another cable and some end to BNCs. Anyway, so let's take a look at the Sony here. I mean, this camera. Anyway, we're on AM, and we'll see what we've got in the way of power here. And key down. All right, we got 20 watts, which is good. That's what it's supposed to be, or around there. And 1, 2, hello. 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 1, 2. Wow. 1, 2. Wow. Oh. I think 1, 2, 3. Yeah. I'm just going out past the ability of my clip leads to be able to handle the power output. There we go. 1, 2, 3, 4. Looks good. Sideband. Upper sideband. Yeah, there we go. 1, 2, 3. And power for upper sideband is right there, about 8 watts. So that's working. Now let's see if I could figure out a way to get this thing up to a more power. Hang on. Okay, I've got it hooked up to the temporary power supply, the big one, and we'll just do the whistle test on it and see what we got. Looks good over there. There's a lot of noise in this room, and the whole thing just fell apart. Okay, it's hooked up, back up again, and hopefully it'll stay hooked up. It's on the 60 amp power supply, and we'll give it some audio and some microphone. Hello. 82 watts is what it hit. Horrible way of testing it, but that's the way it works. On AM, about 20 watts, and it looks fine. See, 1, 2, 3, 4. Yep, that looks good. And it's 80 watts. Or, well, 20 watts. And frequency error for 7200. 50 hertz. 40 hertz. 50. That's perfect. That's great. So, it works. Didn't do receive yet. So 70 dB down, 7,200, 100, about 111. Yeah, looks like, well, that's pretty good for 111. When I put in the attenuator, it goes away. See? Supposed to. 10. Yeah, about 10 dB. That's what the attenuator's good for. So, that's about right. And it all works. So, cool. We can put it back together and give it back to him, and his LED works, or light works perfectly. All right, guys, that was a lot. Let's okay. Phone rings, of course. All right, that's it. That's good. We're going to put this thing back together and give the guy a call and tell him it's working for him, and his panel light works again for the meter. Hey, thanks for stopping by, guys. We'll see you later. Don't forget to like this video and give it thumbs up if you want to. I hope you do, because I can use all the likes I can get. There we go. So, until next time, see you then.